I'm Chief Sustainability Officer at Tesselo. We are a green tech company based in Portugal. So, in a nutshell, we were founded in 2017 in Lisbon, and our goal is to help organizations become more sustainable using open space data and AI. So, our bet is really to focus on free data. Which is why we are currently working mainly with the Sentinel program, and in particular Sentinel-2 and Sentinel-1. So our technology, well, is pretty similar to what you've heard recently with the CVSense. So we ingest raw satellite imagery, we automate all the cleaning, atmospherical correction, and we then run our proprietary AI model to reveal the insight that will best fit our clients' needs. So today, we have also developed our own proprietary platform, and we deliver all the information through this. So our main sectors of applications today are forestry, so timber producers in Portugal and abroad, and infrastructure monitoring, managing the vegetation around critical infrastructure to prevent encroachment, forest fires, etc. I'm going to focus today on our use case in Portugal with CELPA. CELPA is the Portuguese Association of Pulp and Paper Producers. So in Portugal, it's a critical area because it covers about 200,000 hectares, and which are widely spread over the country, which makes it very complicated and expensive to cover and monitor by hand or by field visit or by drone. Our history with CELPA goes back to a few years ago. So we started with, it's a really long-term collaboration. We started with pilot projects about pest detection and tree species differentiation. And we are now up to a subscription basis. So we have a long-term contract with them, and we monitor the 200,000 hectares of plantations on a monthly basis, actually on a continuous basis. So the first phase is a national forest inventory, and they monthly get these 12 classes land cover with, of course, the species that interest them. We also provide an estimation of the cut areas, of the burned areas, because Portugal is particularly prone to forest fires. And next year, well, this year, we're going to start developing some extra features. So differentiating tree age to help them forecast their production, growth, etc.
Apologies, apologies, Marine. Sorry to interrupt you, but I think we're still seeing the same slide. So we're still on slide 1.
Oh, okay. So you're not on the right. Okay,
Perfect.
so I'll just go back. You have just, well, that slide was pretty easy. It's the very short description of the technology, from a raw to a very clear image that we make accessible through our platform on the right. This is the classification for CELPA. So 12 classes, 7 of them are forest, and we aim at reaching at least 20 classes by the end of the year. As you know, for each new tree species, we of course need training data, and this collaboration with the pulp and paper producers is really strategic because it gives us access to very diverse and excellent quality training data. Land use, land cover. So here, I'm just going to give you some visual examples because that's really more interesting. So we use time series deep learning, which makes our analysis aware of the historical context. So we differentiate land use and land cover. The timber producers are interested in land use. So in this example, on the first image, we classify pixels not according to what we see today, but according to their what they are in general, regardless of the seasonality. So on the left image, on the top image, for example, you can see recently logged areas, but even if they have been logged, we still classify them as eucalyptus, because we don't want because we want to account for the total area of eucalyptus at a precise moment. Same way, So here, another interesting feature that was requested by our customers is the cut monitoring. So they know, CELPA being an association, it gathers all the pulp and paper producers of the country. And for CELPA, it's very useful, instead of requesting the information to each member, to have access to an aggregated information of what has been cut this month in Portugal. So above the satellite imagery, the RGB images, and below what our model outputs. So as you can see, it's rather accurate. Same example with burnt areas. So we now have, I think the accuracy is around 94% of accuracy for detecting burnt versus cut areas to differentiate them. So at 10-meter resolution, you see from June to July the extent of a fire that took place in Vila do Bispo in Portugal last year. And the third image is the output of our model. Now, some perspective. The first one is on the tech side. Our most recent scientific breakthrough, I would say, is the implementation of a super resolution model. So it's the same feature that, for example, Google used to enhance the resolution of a face. I don't know if you have seen this example recently. It's been trending. So a very blurry image can be rendered more smoother and more accurate by the super resolution model. So that's what we are doing, which means that concretely we train our models not only with high resolution imagery. This is only possible because some of our clients in the infrastructure sector shared with us some LiDAR campaign data that have been conducted. So we train the model with data high resolution at 40 centimeters. And then we run the algorithms, the models, to detect forest on Sentinel-2 images, 10 meter, and the output is actually 1 meter. So it doesn't mean that the final accuracy is going to be at 1 meter. In general, we are now around 3 meters, which means that the forest line we can be off by more or less 3 meters. But it's still very useful, for example, to monitor the compliance of distance between forest and power lines. A 3-meter resolution makes a huge difference compared to 10-meter resolution. So that's what we've been developing recently. We want to apply it to more and more. We want to apply to all our services. So this is another example, actually, with a power line. High resolution, Sentinel-2, and the model output. What's next? Still in the forest area. Well, we want to work more on fire risk. So we are part of a research consortium of 20 members in Portugal, including the timber producers, but all other forest owners, public universities, researchers, Superior Institute of Agronomy, etc. To develop an integrated management of forest fire. We will be providing remote sensing data, but we are also prospecting other environmental forest applications. We want to work in the forest insurance sector, penetrate maybe the market of carbon offsetting with measuring carbon sequestration, and other monitoring of reforestation projects. We are open to proposal of collaboration. For example, we are giving access to our platform to a research center in Portugal, and we are happy to explore that kind of sharing with public entities, but also complementary applications from startup or any kind of stakeholder. Thank you very much, and don't hesitate to reach out to me, marine@tesselo.com.